Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Weaveworks. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but before I turn the floor over, I have just a couple of housekeeping notes I'd like to review with you. To start things off, today's session is being recorded. So if you miss any of our discussion today, perhaps you'd like to rewatch at a later time, or of course you can share with your team. You will be receiving an email with a link to access the recording on demand. If you'd like to engage with us today, there are a couple of options for you to do so. The first option is the chat tab, which you'll find on the right side of your screen. So if you can see that chat tab, I'd like you to go ahead and test it out for us by letting us know from where in the world you are joining us. Now, for specific questions today, we are going to be holding more of a formal Q&A session toward the end. So please send in your questions to the Q&A just to make sure we don't lose them, and we would love to address as many of them as we can. So sending in your question to the Q&A helps us keep track. Additionally, if you check out the handouts, there is a single handout for the slide deck, but if you look through the slides on the slide deck, you'll see there are a number of other available resources built in. So of course, feel free to download those as it will be a big help with following along in today's program. And of course, before we close things out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around to see if you're one of our lucky winners. So our topic today is building platform engineering best practices on Microsoft Azure with GitOps. And I'm joined today by David Tesar, Principal Product Manager at Microsoft, and Steve Frazier, Consulting Reliability Engineer at Weaveworks. So David and Steve, thank you both so much for joining us today on Techstrong Learning. Steve, do you want to go ahead and get this conversation started?
Yeah, let's do it. Microsoft and Weaveworks has an incredibly in-depth partnership. We have developed Azure Arc together. We have made a GitOps Flux extension with AKS, as well as served many different clients in different industries, such as the financial, technology, and telco industries. We've also integrated the Weave GitOps solution into VS Code with the VS Code extension. Please check that out if you can, as well as we have currently just published and working on a GitOps program offering in the Azure Marketplace. Please take a chance to check it out if you get a chance to check it out. After that, over to David.
Right on. Well, platform engineering is really a natural evolution of maturing DevOps organizations who have a growing number of application teams, right? What happens, as I've seen this numerous times, is teams all kind of have the run it yourself, do it yourself kind of attitude of that team, and they realize there's a lot of work in the infrastructure. There's a lot of complexity. There's a lot of different moving parts, and there's a lot of duplication of effort. It's like every single person trying to create pipelines, every single person trying to create an actual infrastructure as code, and then automate all these things, right? This is as you grow, it becomes unmanageable, and then the natural solution for this becomes a platform engineering team that supports the development team and acts as that bridge between the two worlds. And so some of the common things that these platform engineering teams will enable are developer tools, self-service portals. There's a number of different things that are common so that the teams that are developing your business mission critical applications can be more efficient. And so really it's just as you grow, it's just a matter of time before you really have to have this in your organization for efficiency. Then the next question comes really as well, what does GitOps have to do with this? How does that relate at all to platform engineering? First, I want to make sure we understand what is the definition of GitOps. If you go to opengitops.dev, these are 4 solid principles that we have to define what is GitOps. It's declarative, it's version immutable, it's pulled automatically, and it's continuously reconciled. And so when you have all of those things in place, and we'll get into more of what that looks like practically later in this webinar, but when you get all of those things moving, you realize like, wow, this is a really powerful core glue to making platform engineering happen, right? And GitOps can provide a way to abstract, right, all of this complexity underneath the hood for your applications, right? So what you're going to see is how these applications can get deployed and run all behind the scenes using this GitOps principles, as well as clusters, right? Clusters spin up, spin down, get managed, with GitOps being what's powering all of those things under the hood. So there is variations, right, on how to make this happen. And what I've seen sometimes is that some people say that GitOps equals, I've got some infrastructure as code, whether it be Terraform or whatever it is, and I have a pipeline that connects to that Git source and pushes things there. That actually is only half of the Open GitOps .dev definition, and you really miss out on the full power of GitOps, meaning such as the automatic reconciliation loops and pulled continuously with an agent, right? Those things are extremely critical to enable the GitOps at a full scale. Because if you don't have that, you are going to be at a disadvantage, and you're not going to be able to really achieve the scale that you need. What are some of the practical things in this platform engineering world? So really with application teams, right, when you've got all of this going on, what are they desiring, right? They're desiring some form of self-service capability, such as, hey, I want to not have to think about a cluster, and I just want it to pop up for me. Give me an environment that works, whether that's my local dev machine, whether that's something in a staging environment, or an actual application. Right, there's so many different stacks, right, of the things that run under the infrastructure, right? So the metrics, the monitoring, all these different things have a lot of different tools and possibilities. So the platform engineering team should be able to provide that for them, and they can just say, "Click, I want this stack or whatever," and give that to me, so then I can debug it and deploy it and test those things beforehand. Platform teams, of course, now they're dealing with, well, I have hundreds or thousands of clusters. How can I see all of these things in a central way? Or how can I detect problems, debug or troubleshoot problems with the underlying infrastructure that's going on across all these regions and all these clusters everywhere? How can I make it also easy for these application teams to provision that infrastructure? Right? If they we want to make we don't want to have to define 100 different snowflakes for each cluster. We want to have a centralized way that scales to all of our teams to push these things out. And so I'm going to hand over to Steve so he can start to give you some tips on practical ways that help with making this scale happen.
So when we interviewed a lot of our customers and how they are struggling in GitOps, there's a couple fundamentals we took out of the interviews, and we developed a series of best practices. So when we looked at struggles within the developer lifecycle, customize is incredibly powerful, but you can really dive yourself into a deep hole with overlays. So we found that while doing GitOps at scale can be difficult, it's important to teach these fundamentals to your development team from the platform level and continue to evangelize that. So some of the evangelization points we want to focus on here, and it's pretty prevalent throughout our presentation, and we're going to call out it as we work through our demo, is keep it simple. Divide configuration into static versus non-static patches. Now, a definition of a static patch would be environment-specific configuration, low frequency changing. So this would be something like an FQDN, a specific environment database name. And then a non-static patch would be something that would be such as a version override. And these will have a high frequency change, as well as you can promote this with GUI promotion with Weave GitOps Enterprise. The last thing is we sat down with our customers. Now, we will demo templates here shortly, but this is a practice that has been used throughout the various GitOps practices. Now, if you're using our enterprise product or only the open source templates, are prevalent in self-service functionality. And part of that self-service functionality, we found that it's incredibly important to keep the majority of the configuration and do not repeat yourself standard. This is keeping it in customizations that rely on a different data source instead of re-rendering those objects throughout the different pieces. Now, as a part of these configurations and these best practices and what David stated before regarding the self-service capabilities and those customer requirements, we developed a new set of technology called GitOps sets. This allows platform operators to have a single definition for an application of multiple environments and a fleet of clusters. I'm going to go into a little bit more detail of the actual configuration here in the next slide. But in summary, we combine these with templates and generators. Now, what are generators? Generators are think of it as a data source. After you've invoked a template in self-service functionality, we found that most customers were asking, when was this file re-rendered? Is it out of date? So this is where this technology has come in and really assisted our configuration across the board. It also allows you to simplify your overlay folder structures, going back to that previous best practice that I've stated before when you're building a GitOps platform. And it also allows you to scale this configuration where you're building on top of each other for multi-management applications. Let's dive deeper into a GitOps set. There are a few different components to a GitOps set. The first one is a generator. This is dynamic functions in a GitOps manner that can act as a data source for the rendering of that template. So we support numerous generators, such as a list generator, a pull request generator, so it sits there and watches the repository. If it sees a pull request and matches a certain set of conditions, it will create that object based upon that condition. An HTTP client, so it can connect up to enterprise APIs. We have the GitOps cluster generator that can use a GitOps cluster to trigger off it based upon matching labels. This means you can conditionally deploy GitOps configurations. And the second piece is we have a processor. And this is where the GitOps set controller fits into. Its job is to render that template based upon that CRD and export that customization as listed on the right side. And the resource appliers is the controller that act on it after the fact, after it's been applied to the Kubernetes API, such as Flux.
Okay.
So
the cluster API, I'm the product manager for CAPZ, but I want to orient folks around some of these terms because there's a lot of acronyms out there, and so you can understand what cluster API is. Cluster API is a little bit of a meta. It's actually using Kubernetes to provision Kubernetes. So that's why you see the little turtle icon there, type of inception thing going on. So you use Kubernetes CRDs to provision Kubernetes. And provisioning of Kubernetes can be a self-managed cluster, meaning you run the master nodes. You're basically building and running the full thing on top of virtual machines. Or it can mean a self-managed Kubernetes, where, for instance, different cloud providers, AKS, GKE, AWS has EKS, right? All these things are being provisioned also via the cluster API. So cluster API provides a common CRD definition across various providers. So you'll notice there's 27 plus infrastructure providers, all the major cloud providers. There's also, I listed just one, there's Metal 3, which is a bare metal provisioner. So this can be, there can be all types of providers. We'll see later, vCluster is another one. But that is the base framework, which is a sub-project of SIG cluster lifecycle. So it's not just for provisioning clusters, but it's also for managing those clusters as well. And this really enables the GitOps pattern of that full reconciliation loop, right? This is when you utilize this YAML, Kubernetes is now being used to provision and manage all of your clusters, right? And cluster API provider for Azure, of course, is provisioning either the self-managed or AKS clusters. And then the cluster API operator is just a different way for the install that I thought people should be aware of, because when you are, let's say, utilizing cluster API to provision clusters at scale, you likely are going to have, let's say, a couple hundred or more clusters being managed on a single Kubernetes machine. And having that operator used to install the plumbing helps you to better manage the management clusters using that Helm chart and the operator itself. The other thing, though, is that, of course, CAPZ really only provisions Kubernetes clusters. So, that is going to only really get you so far with what your needs are for your enterprise. And so, well, how can we enable this pattern of having Kubernetes manage your resources in a GitOps native way? Well, that's where Azure Service Operator comes into play. Azure Service Operator has Kubernetes custom resource definitions, or CRDs, to be able to provision really any type of Azure resource that is available there today. I say the asterisk because there's 150 and growing. So there's, it is an open source project, as you'll see. So, contributions are open as well there. Same with the Cluster API and CAPZ. So you have that cloud native mechanism for being able to use GitOps, the reconciliation loop. The other nice thing I'll say about Azure Service Operator is that if you are new and trying to transition to this GitOps way of managing your infrastructure, there is a way with Azure Service Operator to have resources that are already deployed and then convert those into a ASO native YAML, and then start to transition your traditionally deployed infrastructure via whatever the means are into this operation. So we're going to have some demos that happen here, but first up we have what is our scenarios for the 3 demos today. Well, I am going to play the part of a application developer from Fabricam, and I'm of course responsible for maintaining, updating the application in all of my stores for Fabricam Fabric. And I also have to manage the tables, the databases, everything that really makes that application tick, right? Ideally, I don't want to have to think much or at all about Kubernetes. So yeah. And then Steve, he's a platform, operator release manager for the Fabricam store infrastructure, right? He's going to be responsible for setting up the templates, for rolling out new stores, and also rolling out the release of those applications across all of the stores in the whole globe or nation, wherever, at the scale operations and managing that infrastructure. So what does the infrastructure look like? So this is important to break down because there's quite a bit of things going on here. So this is important to understand how things work. First up, we have 2 different repositories here. The core one that's going to be powering really most of this demos and the infrastructure is this infrastructure repro. This is our webinar repo, and here we have the GitOps sets YAML. We have the cluster API for Azure YAML, and then we also have, you'll notice, references to a number of different app repos. And this is kind of highlighted by the actual dashed dotted line across the top here. With that, we can see the reference to app. So you could see how you could have multiple applications repositories here, but that uses that customize to kind of have, let's say, 1 or 2 lines that reference 1 or more applications. So what this really does is it enables a power of scale. So for instance, here, I'm going to undo this here. What we have is this application, technically, even though it is being referenced as a couple lines here in this management cluster, the management cluster is what's provisioning all the infrastructure. It's provisioning the databases. It's provisioning the Kubernetes clusters. it has Weave GitOps Enterprise installed on it. These clusters have also agents on them, the Flux agents, and those are going to be pointing to one or more actual application repos. So we have one definition, right, for the actual app. So once we update this here, assuming that, we're leaving the app references the same, which we likely would, right? Just the actual app itself. The versions may change, but the actual guts of the app and the chart and everything would happen from the developer standpoint, just in this application itself. So there's not multiple copies. There's just one application to maintain, and all of these clusters would be able to get that dynamically pulled down from the agents that get installed. Likewise, you have the actual clusters themselves dynamically being provisioned from this management server right here. So this management server is in a reconciliation loop as well. These green arrows pointing to actually provisioning in a reconciliation loop, not only the cluster, but also the Azure database itself. So you have Azure Service Operator provisioning, configuring the database, also provisioning, configuring the apps that are installed on here, as well as the cluster itself. So this is one place where in Git you have the infrastructure defined. The management cluster is in a reconciliation loop, making all of these resources as it should be, as defined it is in Git. So that is the breakdown of the infrastructure itself. And with that, I'm going to hand it off to Steve to try and make this a reality and help solidify a lot of these concepts here.
Awesome. Let me go ahead and share my screen. So this is the deploy the store template. This is Weave GitOps Enterprise in the templates list. Templates in Weave GitOps Enterprise are incredibly powerful for scale. It allows a user, a platform engineer, to develop a self-service portal for an application developer. This portal can be anything that the application developer needs. Now, this single template is deploy the store. It is a cluster type template, but templates can be any type. It can be native Kubernetes manifests, which will create resources behind the scenes. To deploy a store, this is a rather simplified template. We have a resource name, a store number, and a store environment. So our first resource name is Dallas. Then we have the store number, and then we can select a store environment. We're going to go ahead and select North America, and then go ahead and select the store number. From here down below, we have the ability to create the pull request and define what the pull request is going to be. We can select many different repositories. So these could be exported out to various different tenant resources, such as individual development repos, or all in a single infrastructure repo. We have a single infrastructure repo here today. Let's go ahead and create the pull request, which we just did, and then we're going to navigate to github.com. Here we have a single file changed with one commit. Let's check out this file. Here we have two resources. We have a GitOps cluster. This is a Weave GitOps Enterprise CRD. This describes the cluster for the Weave GitOps Enterprise UI. This includes a cluster API reference down below and labels up at the top that really just describe the cluster at all. So we will actually be using those labels to deploy configuration later on. But today, let's go on down to show the rest of the file. Here we have a customization, a Flux customization. This is a declarative description. I'm telling where Flux to apply. Here we're going to apply the customized folder /cluster/Azure. This will create a Azure cluster behind the scenes. As you can see, there's only 44 lines in this file. and it's creating an entire cluster with just 44 lines. We could even move the GitOps cluster above directly into this customization to make it even simpler. And then we have provided simple post-build substitution rules to the manifest. Let's go ahead and merge this to kick off the infrastructure deployment process and delete the branch. Now we're going to go ahead and navigate back to Weave GitOps Enterprise, where we will go to the applications page. Now, even though we created a customization for a cluster, it will still show up underneath the application page. In Weave GitOps Enterprise, an application is a Helm release or a customization. From here, we can see all of the applications that are across my various clusters. Let's go ahead and search down to the Dallas cluster. Here we have various different applications that have been created on this. Let's navigate to the customization we just created in the previous step. Down below, we see all of the different entities that are associated with this customization. This single customization created a cluster API cluster reference, an Azure managed control plane, an Azure managed cluster, and a machine pool. A machine pool is just a node group in CAPZ terms. Let's go ahead and navigate to the cluster API reference. This brings up the cluster API reference. We can see the Kubernetes entity directly in the UI. From here, this entity is used across all the different providers. Here we have providers specific configuration specifically for the Azure provider. As you can see, there's a control plane reference with an Azure managed control plane inside of it. This Azure managed control plane configures the AKS cluster underneath the hood and describes it. This setting has the region included in it. Now let's take a look at the graph. The graph gives us a detailed view of all of the different entities that are created by this customization and how that's expanded upon and acted upon. As you can see, the same resources in the previous tab are included in this specific web page. This gives a user the idea of where things were created, and this is a huge deal at scale as you're lining up additional customizations on top of each other and can be difficult to locate. Now we're going to go ahead and navigate back to the applications page where we have more than just a cluster included. How did we get these additional applications to be installed? If you remember, we used labels attached to the cluster. Let's navigate back to GitHub and view the files changed where we can see the labels that are included. Here we see the Flagger is enabled, we see Fabricant app is enabled, and we see the environment up on the top is North America. From here we can act upon these resources with GitOps sets. Now, GitOps sets can use these resources to act upon them for scalable building blocks. So our GitOps set is searching for this label, these labels. We have multiple, and let's go ahead and navigate to Weave GitOps Enterprise to show the GitOps sets. So on the GitOps sets, let's go ahead and first navigate to the Flagger GitOps sets. This has created 9 resources. Let's go ahead and go into the details view of this GitOps set. From here, we can see that we can see the raw YAML, and I can walk you through the raw YAML. This is a GitOps set for Flagger. As I scroll down, you can see that we're using a generator. As I mentioned before, a generator is a GitOps data source. This is filtering on a cluster selector for the Flagger enabled match condition. When it finds this label, it will render the template below, which is a customization. It will grab the cluster name from the reference and use it inside of the application and apply a specific path for this application. The path is the customized Flagger Istio path. Up above, we have additional configuration, such as health checks and a kubeconfig reference to pass the configuration down to the leaf cluster. It's important to note that there's additional reconciliation that occurs downstream that will decouple it from it long term. Now let's take a look at the Fabrican app GitOps set. This is searching on the Fabrican app enabled flag. This creates two different customizations. It creates the first one, which is an ASO customization, which uses the cluster labels that I described before, which is North America, as an input to this customization to configure a specific path. This simplifies overlay architecture by grabbing what already exists on the cluster when you describe the cluster and using that on the configuration of your application, and then passing a few additional variables that can be used within the configuration, such as cluster name. Now let's head back to Weave GitOps Enterprise, where we can also see there's another Helm release called ASO, also known as Azure Service Operator. From here, we can see that it has installed various different kinds. We see that there is a flexible server, there's a flexible server database, and a create table job. So what has occurred here? So the ASO has created a flexible server, a database on that flexible server, and then we created a Kubernetes job to generate to create the table on that specific database. This allows the application to come up with a fully fresh database on a new cluster working as expected. Let's navigate to the pipelines view to get a good overview of this application. Now, the pipelines assist in the delivery and visualization of the application. We will dive deeper into this configuration in a follow-up section in the next section. So we have stage, Florida, and North America. So as you scroll down, we can see that cluster 111 Dallas has joined the pipeline, and we can see that the entities have been created for this application, and we have a fully running application. This includes a canary deployment and horizontal pod autoscaler. Okay, that concludes our demo. Now we're going to head back to the slides and let David continue on with the next part.
Right on. Yeah, you can really see how there was a lot that we unpacked there, but one of the things I just want to call out that Steve brought up is how he had 40 lines of code. We could definitely have shrunk that down to, let's say, half almost. But let's say those short amount of lines of code is provisioning an entire store. So that, in terms of scale, right, you could provision, let's say 100 stores, and if it was 20 lines of code, right, 2,000 lines of code, and that's 200 stores, right? And so and each store isn't just a cluster, right? That could be whatever you want. It could be, like if you're using Azure Service Operator, you've got any Azure resources you want there for networking or anything else. It could also it could be, just like a K3S server, an IoT server, right? You can use these same principles for all types of infrastructure for scale. But yeah, I want to switch gears now again to putting my application developer hat on, and what does it look like for that person when dealing with scale? Well, what a lot of times, the developer wants is to be able to have full access to the environment if there needs to be any kind of debugging or tweaking or changing, right? If there's some setting that needs to be changed on the underlying infrastructure, you may not want to have to understand all of it, but you want to be able to have the full ability to debug it or tweak it if needed. The other thing is you want those resources on demand, right? You don't want to have to wait weeks or months, to get a new, infrastructure or resource set up. And that you want it on demand, right, in minutes. You also, from a business perspective, of course, you don't want this infrastructure sprawl. Every second counts in terms of how much the businesses are spending. So you don't want long running clusters. You don't want to wait a week or a day to get a cluster and then have it sit idle for a long time. And then the last but not least is that developers want some kind of tools to help them with that abstraction, right? So GitOps definitely helps with the foundational principles, but there are quite a few different tools out there that help with that abstraction from the local development experience. So you can see a number of them there. DevSpace, Acorn, Porter is a bundling tool to kind of consolidate some of those things. GitOps Run is from Weaveworks. The Azure Developer CLI is another thing. There's I'm sure many more options that are out there, and we're not going to have time to really cover all of these tools in detail, or even any one of them. But I think it's important to call out as kind of a foundation for a modern development experience to have something there. So what we are going to show off, though, is this actual flow here. And what happens, the scenario is that a developer has a pull for some kind of change, and we want to dynamically create a full environment based on that pull request so that we can do various operations. Well, how does that work? Well, what we do have is we have this GitOps set pull request generator that's sitting there monitoring for pull requests against the Fabricam Fiber application. It then detects, in our case, we have some code set up so that it detects when there's a label added to that pull request. That then, when that label gets added, that triggers a workflow behind the scenes here where we create a minimal amount of code using the customization. It uses that cluster source, the branch source code to create a V cluster. The V cluster is that little V symbol there on the right, and the V cluster under the hood provisions a K3S Kubernetes server. So it's a very lightweight Kubernetes cluster that functions and feels like it has, a full Kubernetes experience. So you can use your common Kubernetes tools like kubectl and the likes, but it enables you to provision a full environment based on those common definitions. And so therefore, with that PR, we spin up in minutes the full environment and enables that developer to be able to connect to it if needed, to test it or do whatever else is needed. So with that, I am going to go ahead and demo this developer experience. And so give me a second. Okay, so here I am in my console and on the Fabricam Fabric application. And I'm just showing off the Helm chart, as you can see here, for Azure Service Operator, which is where we provision our MySQL database. The Helm charts are a foundation for really the scale operations, right? And you can have customize on top. Again, you could add your dev tools on top. So for instance, if I wanted to spin up the full environment locally, I could just do, let's say, DevSpace up or AZD up if I were to make something like that work, and have that full environment running locally. And that is one Helm chart that's going to be used across all my clusters on all of my regions with this GitOps framework. So I'm going to go into server.js and make a change. I want to add a cachemire option for this. And I'm going to go ahead and commit the change into my environment. Commit cachemire option. I'm going to commit and push it. And after this, I'm going to then, yes, I want to publish the remote branch. And then, yep, I'm going to go ahead and create a pull request based on this change. Let me create it. And so right now, this pull request, right, let's say that I want to have another group test it out or myself test it out again, just to make sure that whatever my changes are going to look right once they merge to be deployed to all of my different environments. If I really wanted to double check, what I can do is I can go in and add a new label. So what I can do is, in our case, since we've hooked up this to add a label as the environment, the option that triggers the cluster, because of course you don't always want to enable a full ephemeral environmental PR, but in this case, I think this change might warrant it, right? And I want to make sure it looks right, and I can test it out, potentially myself or with others. So after I do that, I'm going to go ahead and go to the console, and I could see in the Fabricam app pipeline, because of the way we have things set up, it automatically generated a dev stage in my pipeline and this PR22 cluster. This PR22 cluster, again, was spun up dynamically. We have the full environment running. As you can see, we have a dashboard application URL associated with the PR. We can see the Kashmir option now there in the app. I can click on that. And then I also have, you'll see in the YAML definition of what got deployed, all the way behind the scenes using that template is down below, you'll see that there is a Azure Service Operator, a database host name. So we deployed a brand new MySQL database in Azure using Azure Service Operator. And this chart automatically not only provisioned the front end, but it provisioned the back end, connected those two things together via that YAML definition. And so right here, we have this full environment only on a PR. But what if I want to debug it? So for instance, I have, oh, wait, I noticed there's cotton and silk here as opposed to cashmere and silk. What do I do? What if I want to debug this thing and figure out why that part is not working? Well, what I can do is I can go back into the Weaveworks console, and I can go to the cluster, the V cluster that automatically got created. And once that shows up here, I can scroll down and find the PR22 cluster that got created. I can download the kubeconfig. You'll notice that it's right there. I just clicked on kubeconfig on the left side. That downloaded the kubeconfig file. And then with that kubeconfig file, I would be able to use my regular kubectl command line to connect up to that. Now, of course, there's different ways, again, with your development abstraction tools, DevSpace or the likes, you can abstract, or your local, VS Code extensions, you can abstract this operation, but we're going to use the vCluster CLI to connect to that PR22 cluster using the kubeconfig. And I'm just going to do a kubectl get pods just so you can see all the pods running there, right? You have, I'm going to briefly show this where you can see the pods, and that runs on my full application from that vCluster is what you can see. So once this comes up, yep, you can see the pods there for all those things. We're going to go back to the pull request and close that out. So once this pull request is closed and merged, that also dynamically deprovisions and gets rid of the vCluster behind the scenes. So all of those things and those resources are cleaned up, so we're not spending any money unnecessarily. And so right there, you've seen how very quickly the GitOps and infrastructure as code is powering this full self-service experience based on just a PR. So with that, I'm going to go ahead and hand over back to Steve.
Awesome, thank you. So what are the next phase of that? So David just deployed a new application to development environment and tested it and then promoted it to our staging cluster. So as a part of this scaling GitOps application delivery, what we have found is that developers need multiple tiers of application promotion. They need a, let's say, quote unquote beta group. They need then a GA release group. This allows you to orderly release your clusters from end to end, as well as we found that there needs to be handoffs between the platform operators and developers with different approval steps. This is incredibly important for where you're going to structure your GitOps repositories and how you're going to do your approval stepping. As you've noticed, he's been working inside of the Fabricam repository, where I've been working inside the infrastructure repository as the release manager. And as well as the developers need to trust the platform, trust that the platform is going to take care of them in the canary deployment waves and protect them against bad releases. And also, finally, developers want automated waves. So enter pipeline. Pipeline allows you to define a route from your application to take to production. It gives you automated code rollout between environments with requiring ops teams manual intervention. It enhances the visibility of the code rolled out. And it also allows you to have automatic rollback in case of failures and changes. So now that I've kind of described to you what a pipeline is, let me mock this out in a quick drawing. So as you can see, there's the Fabricant application chart right up here. This application chart is released and ultimately owned by the application development team. We also have the application config and deployment config, which is my responsibility as the infrastructure operator, as well as the release manager. From here, as it first releases to our stage environment is going to automatically pick up that change. So our development environment tested that Helm chart before it was merged and ultimately released. Now we're going to take the next stage and go ahead and release that chart, and then the stage application cluster is going to pick it up. After a successful installation, Flux is going to send an event to the Weave GitOps pipeline controller, which will then make a commit to the infrastructure applications repository for all of the references for that specific version and update the version. And then the release manager's responsibility to take over from that piece. From that perspective, it will then, and then after you merge the PR, you will go ahead, the new Florida environment will pick up that change down below. Now let's go ahead and see this in action. Before you do that, let's discuss the Canary piece of that. How does Canary work with Weave GitOps, Flux, and Flagger? So as the commit is made to the repository to update the Helm chart, a new version is then created in the staging cluster. A GA deployment here is created, and a Canary deployment is created. Flux and Flagger will then also create a gateway reference, a service entry, and route traffic accordingly to the specific levels between those two different simultaneous deployments. And as the shifting traffic occurs, Flagger will continuously call Prometheus and evaluate the metrics for those configurations. Okay, now that I gave a quick overview of Canary, let's dive directly into the demo. So this is Weave GitOps Enterprise pipelines. Again, this is my stage environment, our Florida environment, and our North America environment. As you can see, we have deployed our new environment to staging. We have done that, and you can see that we've attached additional metadata to allow us to navigate to this application. As you can see, the Cashmere application has been promoted successfully to our staging environment. From here, we can see that the next one on the list is Florida, and the version that has been deployed in Florida is version 5.16. So we are behind. We are going to want to promote this application from staging to Florida. And we can do this by selecting the pull requests menu up on the top right-hand corner. From here, we can see that there's a pull request version ready to be promoted to our Florida environment. Let's go ahead and open up this pull request to review what the pipeline has committed. The pipeline has made a version bump similar to image promotion occurs in native Flux. It has bumped the Helm chart version from 1.5.16 to 1.5.19. From here, we can go ahead and navigate back to conversations and merge this pull request. This gives us our new application deployed in the reconciliation group and will deploy to Florida. But now that we wait for this to deploy, let's kind of talk about how this pipeline was created dynamically with GitOps sets. A GitOps sets was created called pipelines GitOps sets. This has one resource created, and this creates the pipeline resource that I have described before. Let's go ahead and check out the YAML for this application. If I dive down deep into it down below, we can see that we are using the same generator as before, clusters, and looking for various different labels for different release groups. Here we have our dev stage and prod group 1 and prod group 2. Those are mapping to specific labels. Now down below, it's creating a customization as well. From here, it's creating a customization for a pipeline and then patching in specific environments for this dynamic pipeline configuration. This loops through the array similar to how Go templating works in Helm, and it will apply the configuration to this specific piece. Now, prod group 2 will be next on our list. And it is applying a specific path. So now that you've seen the GitOps set and how it dynamically creates pipelines, we can then navigate to our stage and take a look. From here, we can see that, let's go ahead and navigate up to stage. There we see that our application version, Florida, in the Florida stage has been updated to version 1.5.19. This gives you the view of the next view along. Now we can click into the details of this application. And from here, we can see the different entities. We can see that there is a canary object, a deployment, as well as the events that are associated with this. The events include a home test, upgrade, and installation. Down below, we can see that this is installed a canary, which we can see directly in this view, as well as a deployment and auto scale. Now let's take a look at the delivery tab and walk you through the canary deployment. Now, the canary deployment includes conditions that allow you to describe on if this canary has been successfully installed or not. This gives you gates. As you can see, the first one on the list, Miami Cluster 1, has completed all 10 stages. Let's go ahead and navigate into the details view of this canary stage. This gives you a detailed view. As you can see, we have a deployment strategy of canary. We have an application reference, which is the Helm release. And we have an Istio provider configured for it because we are using Istio, as well as the success. It has a successful promoted status. From here, we can see the objects that have been created by the canary deployment, and all of the applications have been completed. We can also see a virtual service, which is the Istio reference, Istio object that has been created, a destination rule, and the way that Flagger creates those for them to route traffic between the general availability release and the canary release. We can see that it first detected a new version, and then it started a pre-check acceptance tense, and then it slowly rolled up the weight from 5, 10, 15, 20% as it stepped through the weight. It evaluated the metrics. It evaluated the metrics on a continuous basis for Flagger. Down below, you can see that it then processed the promotion and scaled down the canary deployment, and then scaled up to the new version for the primary to do the ROS. Let's take a look at the YAML for this specific piece. From here, we can see that we had an analysis configuration for matching on specific application headers to have our first insiders hit the application and be evaluated. We can see that we have the evaluation on error rate and latency at a 30-second interval. It means it gathered 30 seconds of data to do its analysis. It also had a threshold range. As you can see, we didn't promote if it had more than one 500 error associated with this application. And then it has a series of webhooks. It first runs a acceptance test, which will query the canary deployment to make sure that it's up and working with a longer timeout. And then it will go ahead and perform a series of load testing to ensure that the insider traffic will first be valid before shifting more traffic over. And down below, you can see that it configured a specific canary release for this application, which is the Istio gateway, which if this was just meshed directly, this would just be meshed under gateway. And this is what was used to configure the service entry on a specific target reference, which is the deployment itself. From here, now that I gave you a quick overview of the canary deployment, we can go ahead and look towards the pipeline and promoting this application to our North American region. This gives us a quick ability to then review this configuration and then promote it. So let's go ahead and navigate to pipelines. From here, we can see the pipeline again. We can navigate to pull request and pull request, and then we can go ahead and navigate to the pull request that has been created for this North America promotion. Open it up. We can see that the new version has been bumped. Now we're ready to merge this pull request. Go ahead and select merge. And then navigate back to Weave GitOps Enterprise. Go ahead and navigate to the delivery tab, where we can see that the application will start to be rolling out across our clusters now. Okay, now I'm going to go ahead and hand it back over to the slides and David to wrap her up.
Okay. Yeah, you can really see how you're able to roll out like the canary within this system, but also have the platform to roll out to hundreds or thousands of clusters utilizing this framework. So you have a lot of power and control, utilizing GitOps as the underlying core to everything that's there. One of the things we didn't address that we didn't have time for today is just showing how you can actually monitor this full infrastructure at scale. One of the things that can really help with that is the managed Prometheus or managed Grafana service. You noticed earlier there's a Prometheus scraper. Microsoft also has a new managed an add-on for AKS for Istio. So you could use that with Prometheus Grafana to have all your clusters pointing to a central location, and instead of having those local, let's say, things that help you roll out, you could have a centralized dashboard across all of your clusters to have visibility to say, okay, yeah, I'm ready to roll out to 100 stores by looking at this dashboard if you aggregated those together. The other thing that another common thing that comes up as a question that can help out is we have the Azure Kubernetes or Azure Fleet Manager. And what this does is it enables regular, let's say, AKS clusters to join a managed hub cluster. So you could provision those in the same way, which we talked about during this webinar. It could be CAPZ or ASO provisioning those clusters, and then you would just need to join those clusters to the hub. And once you do that, you would then gain some of these additional advantages, such as load balancing across clusters with level 4, propagating different resources across those clusters, and then down the road you would have things like identity being mapped across the whole fleet, layer 7 load balancing, and so there are some additional advantages if you decided to utilize Fleet that would complement what you've seen here today. And there are some things if you did that do overlap a little, like the workload orchestration and the node upgrade images, but you'd at least have 2 levers potentially to pull there. And of course, you really want to have the best practice of all that configuration being in Git as your source of truth, regardless. So with that, we will snap to questions. We're out of time, and yeah, thank you.
Awesome, David and Steve. That was awesome. Those demos went through really well. I learned a lot from watching this. So thank you guys so much for all the work and time that went into putting this together. This has been an awesome 60-minute session. I would like to remind everyone that we have been recording. So if you would like to rewatch this, you will be receiving an email with a link to access the recording on demand. Or, of course, you can find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. The 4 winners of our Amazon gift card giveaway are Lauren N., Matina L., Colin C., and Elizabeth B. So congratulations to our 4 winners. We'll be reaching out to you in the next 48 hours to give you those gift cards. So please keep an eye out for that email. If you don't happen to see it, check your spam folder just in case it happens to get filtered out. I'd like to thank Weaveworks for sponsoring our program today. David and Steve, thank you once again for joining us. And to our audience, thank you so much for being here with us for the past hour. We really appreciate your time, and we would love to hear your feedback. So there is a survey link both in the chat, and if you stick around with us for just another minute longer, you'll get funneled right into it as soon as we close out. But we'd love to hear your thoughts about today's program, or if you have suggestions for an upcoming topic, please let us know. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may disconnect. David, Steve, thanks again.